start it. Yeah, so I think your accuracy is around 81%, correct?
Yes, sir. 83 it says.
Yeah. Validation is actually 81. In the end, yeah, the last one, that's the validation accuracy. This is your training accuracy, training data set.
Yeah.
So if you see in the charts, your so your training and validation is actually it's close by, but what happens normally, as you might have seen in the earlier classes, the validation becomes constant after a certain number of epochs. Training keeps on increasing. Here in this case, it's not. So it's not overfitting.
So then.
Yeah, then you have, okay, so.
And here also the test accuracy is around 81.
Yeah, so 81. So thanks, that's great. We'll move to augmentation now. We'll just probably use this augmentation is in your, anybody who else who wants to volunteer for augmentation code. That's the next stage. So right now, before we go to augmentation, I want to confirm everyone is getting this accuracy, not 81%. Some of you might even have got less. That's not an issue, but can you just tell me your accuracy numbers verbally?
For me, it's 68%.
Sorry, who was this?
Aditya, sir.
Adityan. So 68%. Okay, quite okay. So how many images you took, Adityan?
The same, sir.
Same,
The number of
2,500.
Just a minute. Yes, sir, it's the same.
Okay, fine. So yeah, so anyway, okay, so 81 to 68%. Is a great variation. We will have to see what happened, but yeah, so normally in whenever I do this in class, people get accuracies ranging from 74, 75 to 81%, right? But yeah, some people even get in low 70s. So then we will do the next step. So anybody else who wants to quote, who wants to share their accuracy numbers? So class average was around 13 people took the quiz today. Class average was around 23 out of 30. It's okay. We have highest was 26. I think 2 people have got 26.
Sir, highest is 27, sir.
27. Sorry. Yeah, 27. Yeah, 1% with 27, 1% with 25. 2 people with 26. Then we have a couple of them with 20. 3 of them with 25, and yeah, then 24. Lowest is 18. So okay, I think so. How was the quiz? It was I purposely made it like just limited to whatever we had covered till now. I hope any issues in the quiz, any questions?
Not an issue, sir, but one question where you're asking what qualifies as DNN. I somehow remembered it was minimum 2 in as a hidden layer and 1 input and 1 output.
So it is something, anything above that is deep neural network. Anything 2 and below will be shallow.
So shallow means minimum 4 layers, right? Input
shallow,
2, then output.
Shallow will be, see again, this is not something set in stone. This is something which people tell. Or like
no, I'm asking from quiz question point of view.
Yeah. So anything above 2 should be 2 or 3 should be called deep actually. So two layers hidden and then input and the output. Yeah.
Okay, so that is shallow, right?
Yeah, that is shallow, and anything above that would be deep.
Okay.
Okay, so let's
And there
start
was a
this.
question on what saves time. I
Yeah.
think I had selected. I don't remember what I selected. I have to go and check. But I think the answer was on early stopping.
Yeah. I don't remember the question. Sorry. So you'll have to remind me. I did this at the beginning of the week or something. Yeah.
Okay. I think the question is something like in the deep learning training, what saves time? And the options were like early stopping, dropout, and there were two more.
Mm-hmm. So I think early stopping definitely saves time because based on the criteria you've given for early stopping, it will stop it maybe after 5 epochs. If your validation loss is validation loss is very similar to last loss, it will just stop training. Instead of 10 epochs, it will stop at 5 epochs. So it will save you half the time because the logic is it will not improve significantly even if you run it more.
Okay. Did you give padding also as an option? I think I selected padding because
I might have given some options for sure.
Okay.
I also maybe just to confuse people, I'll give some unrelated options as well.
Okay. I think I fell victim for it. I selected padding,
No
hoping
worries, no worries.
that improves the speed and performance.
But I think you're one of the folks falling in high scoring bracket, so that should not be issue. I purposely want. I would purposely have trick questions as well, right? Just so that people, because this is multiple choice question. I cannot. I can give you this kind of open-ended question in exam, but here I will have to give options. So I try to be tricky in some of them for sure.
Yeah, and
So
one more thing,
Yeah.
especially on the Google Translate. There was one question related to the Google Translate.
Mm-hmm.
Actually, somehow I felt that okay, they use the NLTK to improve their search, especially the BERT algorithm.
No, it was not for search. It was for translate. So translate is a different application, right? Search, then search, and search different translate. As if you remember in the class discussion, there is a very famous Google blog article as well. I can in fact, let me just give you that. That I'll give you.
That is the attention what matters. That is again NLTK transformers, correct?
It's not NLTK transformer. Transformers is different from NLTK. NLTK is a toolkit from in Python, which has been there for like more than 15 years now. Very popular. Google Translate is improved due to deep learning and not statistical machine translation they were using. So Google blog on. There's a very interesting blog. You should all read it. You will find it like you're reading a story. In fact, I think it's a New York Times article. Yes, this is the article. The Great AI Awakening. Must read if you have not read it. It's 6 years old article, but it is a very well written article. In fact, as I said, it reads like a story. Definitely read this article. The Great AI Awakening. So that quiz question is coming directly from this article. Shall I start? I hope there's no other major issues with the quiz. I think everyone has done well. Thank you. That lets me know. That lets me feel that, or makes me feel that you have paid attention in the class. So thank you. Let me share. Okay, actually, I should not share screen. I will continue. Guru, if you mind sharing that. So 30% you got. Maybe we can. I hope everyone is able to run the code now, right? Can you share the accuracy? I'm asking one by one. Aditya, you shared. It's around 68%, right? Which you shared.
Yes, sir. Yeah.
Okay, Ajaz, were you able to run this?
Yeah, it's running. Still, it is running for me. It is not throwing out the accuracy. Still,
No
it is
problem.
under loop.
Okay, okay, no problem.
It-
Let us know when it is done.
Yeah.
Amarnath,
Sir, I'm working on that problem actually. I'm done with up to model evaluation and model summary. Then I'm working on the test data. I'll let you know once I got the result.
model has trained once.
No. Model is not trained yet. I just build the model.
Okay, Amit, I think you done earlier, right? Or you were? Were you able to get the output for the first one?
No, actually in lunch I had to go somewhere, so
Yeah.
I'm doing it's running now.
Okay, cool. Let us know once you're done. You can just type out the accuracy in the chat. Okay. Anand, were you able to do it? First one. Anand is there on the call? I think he's not there. Ganesh, you
Yes,
were able to do it, I think.
yes, he joined and he left, I guess. There is Anand Vijay Kumar is showing here, but I guess there is a network issue or something. He's not
Okay,
responding.
no problem. No problem. Thank you. Pratik. We will just check. Ganesh, you are able to run the first code?
I'm yet to complete, sir.
Okay,
I'll
but it
post
is
here. Like,
yeah, you press the accuracy. We'll
yes.
move to the next one after that. So Ganesh is done. Ganesh is doing. Kaushik, any updates from your side? Okay. Kaushik is not there, I think. Krishna, I think you have done, right? Hi, Krishna, you can hear me?
Hi, sir. Yes, I can hear you. Mine is still not done. I am in training in the full data set.
Okay, full data set. How much? How many epochs have done? Are done?
Let me see, sir. Once.
Your code is run?
No, sir.
Okay, how
The
many
Kaggle,
epochs? Yeah,
no, no, no,
Kaggle.
no. Kaggle was not running. So
Okay.
I started uploading the files on the Google Colab. And in parallel, I'm trying with the Jupyter Notebook also in the local system, if that works.
Okay. Okay, let's hope one of them works actually, because I'll move to the next one. Venkataramana, you were able to do it?
Sir, I'm traveling. I cannot able to present.
Okay, no worries, but you are able to do.
Yeah, sorry. Sorry.
No problem. I think you're outside. You can message us once your code is run.
Okay.
Guru is done actually. Pranish.
Hi, sir.
Hi.
Yeah, it's in progress, sir.
Okay, but
Yes,
it's how many epochs are done?
it's just started now. The
Okay,
first one is.
what is
Yeah.
one epoch is taking how much time roughly?
I want to enable the GPU for that one.
Oh, okay, please
Okay.
enable. Yeah.
Yes, yes.
Okay, so then yeah, Srivalsa, were you able to do?
Sir, I'm
Shiva-
also like doing it actually. This started.
Okay, have you started?
Yes, yes.
So please catch up, all of you. So I'll trouble you again. I think Guru, share your screen. We can proceed with the next approach to improve the accuracy. Okay. I would request everyone, whoever is running the first one, to share the accuracy on the chat along with your. I mean, for the first option. Thanks, Guru. So the next option. So here we used a basic architecture with just convolutional neural network and max pooling. So basically convolute. And we got some accuracy ranging from say 70s, early 70s to early 80s, right? Then let's look at how we can improve this further. So there is something called as augmentation. Augmentation is how you, so one of the issues here is maybe we have the data set is not sufficient, right? So we increase the data set by augmentation where we, so if one image is there of a cat, we can generate 4 or 5 images out of it by making some changes. So the changes can be, you can rotate the image, you can shift it vertically, you can zoom in or zoom out. So these, so this same image can generate more images by doing this. This is called augmentation. In fact, augmentation is a concept which is not, it is popular in machine vision, but it is now also popular in NLP, because if you have very little text data, you can make some changes in the original text and generate copy text out of it, right? Which is slightly different, but it's the same meaning. And that can augment your text data set as well. So augmentation is a technique which can increase your data set size. Yeah, so so there is an augmentation example they have given in that, I think they would have given in the code. I'm just seeing if the augmentation example is there. Yeah, so there is this data augmentation stage to add to an image model. Can you write that code, Guru? If you go back, data augmentation. Yeah, this is the one. So if you see this, you can use a data augmentation section where keras.sequential, you can say, okay, layers.random flip, layers.random notation. The 3 types of augmentation techniques you're using here. You're flipping it horizontally, the image. So maybe if somebody is sitting like this, they'll become ulta. Okay, so they'll be flipped horizontal. And layers random rotation by 10 degrees. You will rotate 10 degrees and it'll create an image. And layers dot random zoom. So 0.2% zoom you're also doing, or 0.2 zoom you're doing. So now let's see what some of the examples, how the image looks. So you are taking one dog image and you are generating this image of the dog. And can you just, why does it all look the same? It is looking exactly same.
Sir, this works only on certain images only, sir. I tried experimenting this.
Yeah. Can you just see? Yeah, because
for one image, it was showing a dog with all different angles. For a second image, it was showing the same dog with the same angle.
Which should not happen actually. There's some issue. So because you are, it should at least rotated dog should be seen.
Yes. So I was able to see on one, but
yeah, actually the same thing happened to me earlier. Once I run, I mean, it was some image I could able to apply this code, but not, I mean, especially on this dog, it is looking a little different.
Which that is slightly strange.
Yeah.
Because it should equally work on all images, whatever image you give it.
Okay.
So anybody else facing the same issue? I know people are catching up. Okay, so
Then we need to run this GitHub notebook as is, or we need to run it on the Kaggle dataset.
see, whichever is comfortable with you in terms, because you need to upload around 5,000 images as well from that data set. Right? I mean, you can upload the whole data set, but you are using only 5,000 images. So that's one thing. So wherever it is easier and faster for you, that is best.
Okay, fine, sir.
So let's just try once, Guru. We can in the others. This one, yeah, not here. Yeah, the augmented code. Yeah, above this where you are. Yeah, here can you change that data set for images in data set train, take 0 and just print it?
1 minute, sir. I'll just re-execute this on the same image and let's see.
Sure. This you're running the test accuracy for the last one.
Correct. I'll just
no
finish
problem.
it.
No problem. Yeah. Yeah, because it's very strange. It should work equally on all images.
See, I think this is also same.
Yeah,
Other
yeah. No,
image also.
So let's just see the code actually, because see, this is a straightforward code. All it is doing is changing things. Need to check this code. Data augmentation, keras of sequential, layers, random flip. See, I think not 36 in 37. What we are doing is for images in trained data set, take one. Okay. For I in range 9, augmented image, data augmentation, image. Can you just print the image? I mean, what is the number of image it is taking? I'm thinking it is just taking one image. Train data set dot take one.
Yeah, it is taking only one image.
Mm-hmm.
See here, if you see augmented image 0.
Mm-hmm.
Let me try this.
Yeah. So it
in
is
code.
printing. Yeah. Just make it augmented image 2 or something in there.
I think looks everything same.
Yeah, it is.
Shall I change these parameters, random rotation and random zoom, and try?
Yeah. Change. Yeah. So do it some higher values, maybe 0.5. Yeah. Yeah, that's a good point. One reason might be they're very small, so it might not look very different. Yeah.
No, sir.
No.
I think
So,
some problem.
no, but yeah, see, this is like one straightforward thing.
Random zoom. Yes.
I just run this old one.
Yeah, the older one. I'm just seeing the 2016 code on keras.io. Yeah, that's like, then TensorFlow 1.x. Yeah, they have given, in fact, a lot of these options. Can we try all of these? I'm just pasting it. But I'm sure there might be some error because, so yeah, but this is like older version of keras. Rotation range 40, width shift range 0.2. But again, this is not the same function. It is image data generator. So we can actually see on some other options of the same function, right? Whatever that function was, it's called data keras.sequential layers.random flip. Let's see.
Oh, it's something different. This function itself looks little different. 0.5 here relays random zoom 0.5 0.2.
Yeah, there is some Stack Overflow thing on this. I am posting one example. Just try if that works. Right. So just take this one. It has see the other code is the same, random rotation and other things. After that, is this? Yeah, instead just take the last line. List all you already have. Dataset.map lambda x dot data augmentation x. If we use a lambda function, okay, so what they're saying is basically when you're running the model, those changes take place. Okay, so that's why you're not seeing it here. In the older 2016 version, it was running. I mean, you could run it and see it right now, but right now what you're seeing is it's just showing you that one image. While you're training the model, it will do those changes along with that. That's what they're saying in that Stack Overflow one.
So in that case, we don't need to do anything changes here.
No, let's run for it. Let's run with it. So right now, and again, if you Google for it, there will be some code where you can. I mean, apart from just running on in as part of the Keras, you can also augment separately. You can write a few lines of code to create 5 images out of every one image, right? So that will help you in future when you want to simply increase your training data set size, right? So that code you can find on Google. You can just check for augmenting images. It will be similar code, of course. Yeah. So let's try that. Let's move then. Yeah, to the. So now, if you see this layer has been, or this capability to augment images has been added in order to improve the accuracy. So if can you just increase the font size a bit, because on Zoom in Teams my screen size is slightly smaller. Yeah. Thank you. That's it. Thank you. Yeah. Yeah. Thank you. So Kera's input shape is 180, 183. See, data augmentation inputs is what they are taking. That's the only change compared to last time. Rescaling is the same. Conv 2D, max pooling, everything is the same. Layers.flatten X is also the same. Okay. Layers.dropout is they've just added a dropout to avoid overfitting. And then see, that's the only change. So that and the data augmentation in the beginning. Now rest all the same. Rest all is the same. Can you have you already run the data, right? What is your output? Okay,
it is almost 100 epochs. So
yeah.
I just stopped in between.
Okay, how
so
much
I can
is the
change
accuracy?
to 10 epochs and then change it.
No, that's fine. That's fine. How much did you run? 100 epochs?
I think it has run 15 epochs.
Okay, so
accuracy is around 79.
No, that is training accuracy. Your validation accuracy is around 50. 73.
Yeah,
okay.
70.
I think, but definitely it will go up. Yes, so they're just to avoid overfitting, they're doing it.
So this will take time.
This will take time. This for 100 epochs, it will take 1.5 hours.
Yeah.
Okay. So anybody who's reached here, so anybody for whom the first one is running. So this will definitely, so what we'll see is this will lead to some amount of accuracy improvement. Now, these were the two things which you could do with the basic convenet. One is just run the convenet. Another is augment the image before running the convenet. Now we will move to a very powerful method. But before doing that, we'll just check where is everybody. Anybody for whom the first image, first thing is completed?
I just completed the first part.
How much accuracy?
And downsize the data. I just run for the 2000 for training, 500 for validation. Max accuracy I got was 0.639.
64%. Okay.
Yes, and the validation was 66.669.
So, and have you also run the test accuracy just in case?
No, I have not run the test one.
No worries, validation will be close enough. I mean, normally validation is not very far away. So yours is 65. So I think Aditya, yours was 68, right?
Yes, sir.
No, my validation is 66.9.
So almost close to Aditya. His was 68 something.
Yeah.
So you're very close. Now, if you run this augmentation one, your accuracy will go up. Please report us. Please report to us or share with us what's that accuracy. Okay.
Okay.
Now, why you might ask, why are we doing augmentation, right? How does it help? So see, one thing I told you increases the data set. Your model has more data to learn, but it might, so you might think, okay, this is a very easy process. Whenever I have less data, I should augment, right? It might not work every time. Why is that? Because your data set might not have that much of variety. And even if you change this augmented images, I mean, if you generate augmented images, the same kind of variety might be there. So that might limit your performance. So even though it increases the performance, it will not increase every time, or it will not increase by a lot every time, right? So keep that in mind. It's a good idea, but it's not perfect because it depends on the underlying data. If the underlying data is extremely similar, I mean, you do a lot of changes, but still not make a huge difference. Just be ready for it. Yeah, but normally it works. So definitely you should try it out, right? Augmentation. Okay, so the next one is VGG16. Before we do that, I wanted to just 1 second. Okay, so let me, can I share screen? I wanted to cover some theory of pre-trained models. So I'm just sharing my screen. Actually, I need a slide, not the, yeah. So I'm going on slideshow mode. Let me know when you can see it.
Yes, sir, it's visible.
So we have done these 2 steps, building a basic convolute. So most of us got anywhere between 68 to maybe late 70s. I think some of you also got early 80s. That's fine. The one of the reason for the differences might be the images you have taken might be very different. That's one of the reasons why somebody is getting 60s and one is getting 80s. But yeah, now using data augmentation, you have increased the data set size. I think 3 times in this case, every image is being generated into 3 different images, 3 more images. Now, using data augmentation was one thing that we will see what is the accuracy once you all share with us. That will definitely improve. Now, the next idea to improve your accuracy is using a pre-trained model. Now, VGG16 was done some 6-7 years back. It's a very powerful model. It's a pre-trained model. It was trained on a lot of categories. I think it's some 100 categories, right? And it was trained on millions of images. And we are using this model to improve our accuracy. You might ask the question, how are we using it? Is it like a zero-shot model? In some sense, it is like a zero-shot model, but there are some differences here. So if you remember, while covering convolutional neural network today, what I told was this, I mean, the initial layer, let's see, this is the first layer of CNN plus max pooling. This is like the second layer. This is like the third layer, and so on and so forth. So the initial layer, as we just saw, or we covered in the morning, captures a very generic features, right? So it will capture, if you are doing a cat, it will capture the entire cat family here, kind of cat family features. But once you go towards the top, it will start capturing very specific features to your problem. So it will just capture cats and dogs features, nothing else, right? So we use this property, what I just said. So we are saying, okay, this VGG16, this is like the convolutional base of the model, right? This whole the area where I'm saying, and this is like the fully connected, the top layer of the model, right? So we will not take this top layer because in this top layer, it is predicting around 80 classes or 100 classes, whatever, right? And we don't need that. We want to predict cats and dogs. So we will get rid of this and we will use only this base to train to in our model, and we will add this fully connected dense network at the top, which will predict cat and dog. Okay, so 2 things here. So this will improve the accuracy. Why? Because we are reusing the learnings of this model where there are very generic learnings at the top, and then we are using this whole learning, and then we are training the model. And while training, only the parameters of this top layer will be updated. This whole thing will be frozen because we don't want to retrain VGG16 on our system. It will be very long. It will take some time, and it will not something we are looking for. We are just using the learnings of VGG16, right? And then training those learnings along with our top layer to predict cats and dogs. That's what we are doing. Okay. And there are two ways of doing it. We will go one by one. One is feature extraction. Feature extraction means you will just take the convolutional base of VGG16. You will input each image here, and VGG16 will convert it into a vector, right? Just like a word to vec model converts a text into a vector, VG16 will, you will give input image here, it will generate a vector of certain dimension, right? And then you will just convert each of your image into that vector, and you will then train a model with all those images as input and the output as your label, and that's it. So that's called feature extraction. We will do it next. The other is fine tuning. Fine tuning, what you do is you will unfreeze some of the layers, okay? And you will then just train maybe the last layer of this guy along with your top layer, and rest all will be frozen, right? So this is called fine tuning. It also brings you goodness in results, right? That's the fundamentals of pre-trained model. How do you use it? Is this clear? Any questions?
Sir, I have a question.
Yeah.
Whenever we have this kind of transfer learning, it's been trained of n number of classes. So it has got all the features extracted already.
Yes.
This adds on to the complexity of layers. So is there any way wherein we can drop the unwanted features?
So great question, actually. So as I said, this initial layers are only learning your features, right? And only learning generic features, which is very, very useful for you, because you are also doing, because some of the classes inside VGG16 are actually related to animals, right? So you have learned animal features here. Now, if you had taken the entire VGG16, then probably some of the other features would be useless to you. But what you're doing is you're taking the convolutional base of this model and then just adding your dense layer at the top. So whatever features it has learned, it will help you in predicting cats and dogs, because those animal features are much more powerful than what you would have attained by. I mean, you would only obtain that or obtain it only when you train on such a huge data set, right? So you are just using the goodness of that and forcing it to just learn to predict cats and dogs using those features, nothing else. So this is what is the unwanted features. As you said, whenever we are doing this technique, we are not training the convolutional base again, which has millions of parameters. We are, I mean, as in the first case, we are just keeping it completely frozen. And in the second case, we are just unfreezing the top layer here, one or two layers, rest all is frozen. So we just need to train a few layers, not the entire thing. So that also helps us in avoiding changes in the model and retraining and learning new features. We are just using the goodness of this model because it has been trained on millions of images. It has features which we can never get. So we are just reusing those animal features in order to help us in cat and dog. Did that answer your question?
It answers my question. I was also thinking about another way which can do the same thing.
Yeah.
I mean, instead of retraining, just add one more layer. And that extra layer would have only save.
Yeah, this is what we are doing here at the top. We are using dense connect layer here with the cat and dog.
Yeah, so one neuron only, right?
One neuron. I mean, wait, that's it. So one neuron for two options. Yeah, that's fine. Yeah, that's correct.
Okay.
That's what we are doing at the top. Because if we continue with VGG16, then we will have 80 other things being predicted, which we don't want.
Yeah. I have one more question, which is slightly different from this one, but thought of asking.
Yeah.
These all are either binary or multi-label. No, sorry, binary or multi-class.
Yeah.
But in case of multi-class, multi-level, what kind of the output last layer should be?
Yeah, multi-class, multi-label, the output last layer would be, you would get output. So instead of it adding to one, it will individually give you probabilities of each class, right? So it will not add up to one. It will just, if you remember in zero shot, there were two options. One was it will add up to one, and in other case, when you enable multi-class, multi-label, it will individually be between 0 and 1 each label. So you are looking at the second case here. In that case, you should use a loss function, or sorry, you should use an activation function which will individually highlight what's the score for each of your potential labels, and whichever is above a threshold, all those labels will be taken as your label. Okay.
I'm not sure. I would like to design one such thing. I'm not sure on what kind of last layer, what kind of loss function, what kind of metrics to use for multi-level multi-class. I'm very confused on this.
You will have to use a, let's take an example. We'll take an example, and we can connect also offline. Because this problem this not a multi-label,
Yeah.
but there would be a multi-label architecture for sure. Let me find an example for you actually. This is slightly old, so you will not have the latest TensorFlow, but so it is predicting both color and clothing type, which is an example of multi-label, correct? So to answer your question, I'm just looking for the last layer architecture if they would known it. Okay, let's connect offline. I will share with you this a good example. This is not a great example. One of these would be a good example on working example. I think even Analytics India Mag. I'm just looking at what are the examples they have.
Yeah.
It's adding convolution 2D, max pooling, second convolutional, max pooling, flattening. Yeah, so this is the one softmax it is adding. So to your answer question, to your question, Krishna, softmax activation function will enable you to know out of these 10 labels. Yeah.
Yeah, softmax for multi-label, right?
Yeah, multi-label.
Yeah, and for multi-class to add?
Multi-class will be, I think we have done it, right? Categorical cross entropy. And what was the one? Does anybody remember in the class? What was the last one? It was, I mean, we'll have to refer the code, earlier one. Which one was it? For a newswire example.
Okay, for example, suppose that we give one record as an input or one object as an input. The output can be either A, B, or C.
So it will highlight. Yeah, go ahead.
No, so it's a 3 class, A, B, or C. Now.
Yeah, so it will add up to 1, and A, B, and C, whichever is highest value is your answer. But in this case, it will individually show between 0 and 1 score for each output, right? So if you have two classes as answer, both of them might come out as 0.8 and 0.8, and the third one might come out as 0.2.
Yeah, but sir, my question is a little bit more extended to this. Within each ABC class, I have three more classes. So A1, A2, A3, B1, B2, B3, C1, C2, C3. So the final should be either A of 1 or like C of 3. So classes, and then within each class, 3 levels.
I got it. So that's you're talking about one of the patents I
Multi-class.
filed in. Yeah, it's a hierarchical model approach actually, because you have hierarchies within each class, within each level, you have sub labels. Okay.
Yeah.
So this is one of the patents I filed last December. We can connect offline and talk about it. I will not be able to really reveal too much details, but I can give you a guidance on how to handle it. You basically divide. You basically divide data and then run models in a loop. It will be run in a loop to come up to the final answer, right? That's the whole idea. So you will have a common defined structure for a model. And whenever, so for example, if there is C1, C2, C3 as a child category for a label C, right? So then you will combine this C1, C2, C3, and then first predict is it either C, right? And if your model tells that it is C, then within C, then you will run another model which will tell you it's either C1, C2, or C3.
So I get it. It means that you say that no single model will help me. I will have to define two models. So one will be for the class A, B, or C, or D, or whatever. And depending upon that, the inner model will run.
Yes, that's one of the approaches. See, why one model can't help you is because you don't have fixed set of subcategories also, right? You're not saying that, okay, within each I might have just two each, right? It's not possible. So then in that case, you will have to run it in a loop where you predict at a top level what's the probability of that parent category. Then within that parent category, you will have to predict the child category.
Okay, I get it now. I try to design. I was wondering how could I do that?
Yeah.
But for both of them, the output should be softmax only.
Yes, softmax.
Okay, so sparse matrix. Okay.
Okay. So coming back to the, so yeah, this was all about this pre-trained. Now that we have the theoretical understanding, let's look at the code. How are we improving the accuracy further? I'll stop sharing. And can somebody, apart from Guru, Guru has already done it. Can somebody share their screen with the, and for anybody, the first one has run. I think, yeah, Krishna, for you, it is 67%, 66.9, you said, right? Guru, what is your epoch result still now for the second one, augmentation?
Still, it is running 18.
18. Oh, 18
18.
minutes. Okay. What's the validation accuracy?
Validation accuracy is around 0.67.
So it has reached 67 already.
Yeah.
Which is quite good. Okay. So who wants to share for? If you can actually maybe use a new Colab notebook in case your old code is still running. All you need is access to a data set for running this one. We'll take this 3:30 break slightly later today. We had around 2:30, so we'll probably take it around 3:45, slightly after. We'll just continue. I hope that is okay with everyone, right? Ganesh, can you share your screen if you can just try this one while your other codes are running?
Hey Ganesh, can you share your screen, please?
I think Ganesh is probably not connected.
Yeah,
I'm
like,
there,
sir.
Okay, hey Ganesh. Can you share your screen, sir,
small
please?
fluctuation.
Okay. No problem. I understand. Happens with all of us. Yeah. Can you please do you mind sharing screen? We can just start this third option while your second option is running. How much have you been able to run that, or what is the progress there?
Mine is still not complete, sir. Going through some network fluctuation, changing between Airtel and Act here.
Okay. So then that's fine. Then we'll just have some. Nidhi, how is your code running?
So the first code completed.
What's the accuracy?
The final accuracy is coming 100%.
No, not trading. Validation. Sorry.
Validation was
Because 100% is your training actually. Can you just share your screen?
73.
Sorry, how much?
73.
73. Yeah, so that's pretty expected. With augmentation, have you started running?
I'm just starting with the augmentation.
Okay, you can park it for now. Can you just mind sharing your screen? We can do the third one, the pre-trained one. Thank you. If you go down, yeah. Augmentation concept is clear. You all can run it and note down your improvements. We can discuss a project on this same thing towards the end of the. Yeah, so this is fine. Leveraging of pre-trained. Yeah, this is the one. So if you can see, this is how you invoke a VGG16. You and we include top equal to false means you are not taking the densely connected layer of VGG16, right? So that's what you're doing. And input shape is nothing but your image shape. So if you can just take it, paste those two codes. Yeah, so it read the VGG16 code. Sorry, VGG16 model, it loaded it.
No, I guess previous codes are running, still running. So
Okay.
it will not start running this.
Will you be able to run a fresh Kaggle notebook and access the data still?
I have to copy paste again, I guess.
Okay, which one? The data portion. You can just copy this code or something. Copy this whole file. Duplicate this.
There is a duplicate option.
Oh, do you want me to share?
Okay, you can share.
Okay. Let me know once it's visible.
Okay. Yeah. So can you just print the conv-based summary? You already can you just show the class what is the conv-based summary? So say this is what the conv-based summary is actually. It first, when you run this code, it will download the VGG16, and then if you see it is different from what we had. So if you see the, you can slightly scroll down. We'll see the So it has a 180 into 180 into 3. Then you see the kind of layers it has. 256, 512. So in the morning, I was giving you an example of maybe an example of a convolution layer where CNN network where you have 512. So this is one of that. So once you pass through this, once you input an image, the output will have that dimension which is mentioned in block 5 pool. Each of the layers has a name, right? So block 5 pool. So your output layer output image will have will be converted into a vector of 5 into 5 into 512, right? That's what it will convert to. And this is so in this method, what you're doing is you're feeding raw image data to this conv base where you have removed the top of it. And then you're converting each of this image into a vector of this dimension. And once you have done that, this is called feature extraction method. So you extracted the features out of each image using VGG16. Now you are feeding these features to a simple neural network, a sequential neural network, where your categories cat and dog, and your input is this feature. That's it. So that should improve your accuracy. Let's see that. So in this one, you are just feeding it to VGG16 and you are appending it in a list. Yeah, so this piece of code converts each of your input image cat and dog into a 5 into 5 into 512 vectors. Hope that is clear. Okay, train data set. Is there a different name in your?
Yes, I took a different name. Let me scroll
Okay,
and
yeah, just to copy it.
And I will rename it.
First
run, delete this one.
Krishna, one more thing.
Yep.
So the train data, you have to reduce it because if you're loading to those images,
already reduced, so no problem on that.
It's like even for 100 images, it's taking a lot of time. So.
Oh, who are you not using GPU then? Should not
I'm
take
using,
so much time.
Okay. Yeah, I'm using the local Jupyter notebook, so that's why.
Okay, but you have GPU on your machine?
Yes, it's there.
For me, it works fine actually, so it's okay.
Okay.
I just need to copy everything from here.
I think it is expecting a different format, looks like.
No,
for train
format
data
is fine. Name was different.
Okay,
so
okay.
I'm giving the proper
Validation
name.
data versus okay, data was set versus data. Okay.
Yeah, now it's all good.
Oh no, last one you need to change. Last one. Data set. What is data set? Okay.
Test data set.
Okay, that's fine. No, it is still giving an error.
Yeah, it says too many values to unpack, expected to.
So I think there is some format thing also. Images, labels. So in data set, the data set has something extra, is it? It is expecting only image and labels.
1 second, I will correct it 1 second.
Yeah, sure.
For images labels in dataset, how many values to unpack expected to? Okay.
Yeah. So data set wherever you are. Data set where is
features
being
in data set.
Data
I'm
set.
giving
Where
it
is
data
data
set.
set?
All features, all labels. So this is the function. I mean, get features and labels, passing a train data. It's receiving the data here.
Correct.
And then for images labels in dataset.
So train data, can you print it out? How does it look? Is it not having two things to unpack? Because you're passing train data here, right? So because that's the error point it is saying, right? So if you can print out train data, how does it look?
Okay, I will do it now.
Yeah.
Image and label, 2 columns.
Image and label. So
here data set.
No, so I know. So I think it is expecting. Yeah, it is pre-processing that image. Pre-processed image, Keras application. It is pre-processing that path image. It is converting pre-processed image to. Okay, is it like happening for each image or is it happening for a particular path in your loop? Can you print out something just to see if it is happening for any particular iteration or and it is running fine for all other images? Maybe there is some junk image in your folder. Sometimes it happens.
Sir, I believe it's a problem on the format of the data it's expecting. So
yeah,
because this line will not work. Actually, I know that why. Because I am passing it a data frame, it's expecting a dictionary.
Okay, so in the Keras in that GitHub code of Franco HLA, what is the data set actually type of? Can you just see how they have created data set?
It should be dictionary by saying this function. Let me cross check it.
Yeah.
Data set copy control F.
Maybe yeah, you can then probably.
Yeah, no, I can run it like that also, but let me first have a look how they did. So for okay, that's the one. Files upload, unzip, get the file path, and then
yeah, it is converting it into vectors. That is what is expecting. Sorry, converting it into number. I mean the numpy values. Yeah. Maybe if you take this. This is the format it is expecting. You can convert. See, one thing you can do is we can use a function to just convert each image into its numpy value, right? It will have 180 into 180 into 3. So we can then store it in that.
We can do that. NumPy values, I can do that like this only. Done.
Okay, let's see.
But I still doubt that it will not work.
Let's see. Let's see.
Yeah. Too many values from impact expected to.
Okay. Is there a way we can just convert? I mean, can you see if it is actually converting it into a proper that 180 into 180 thing, 180 into 3 thing. I mean, the same format it is expecting.
One thing I can try is instead of doing that for images, comma labels in dataset, no. Or
Okay, and meanwhile, folks who are uploading on Google Colab, you can actually, you were following the GitHub link, then you would have already reached here, or you might, for you it might be working. Can you let us know if it is working for you? Anybody on Google Colab or Guru, for you it is working?
Still, I'm running the old code only, sir.
Okay, okay, the other one, yeah.
The other one.
How many epochs?
It is almost now 60, 34 epochs.
34, okay, still time. Can you start a new Colab notebook where you can just copy this one and then just run this features and labels, because we need that NumPy array format for inputting to this VGG16.
Sure, sir. I will do.
Thanks, Krishna. Let us know when you change the format.
I will try on my own first.
Guru, if you can share your screen, please.
Still, I have not done that modification. I will start now.
Sure. We can do a working thing. So one thing which I just noticed is that in the Kaggle notebook, the way they are treating the image is different. But I mean, not treating. I mean, they're taking the raw image, so and that path, and that is what is not suitable for VGG16. VGG16 wants it the NumPy value of the image, basically the pixel of the image, pixel value. Okay, why don't we take a 15 minutes break and come back at around 4ish? Then we'll finish this classification stuff. Okay, let's take a break.
Yep.